Welcome. My name is Nathan de Ruiter. I'm the Managing Director of Your Consult. I would like to welcome you to another one in the GVF webinar series produced in partnership with Satellite Evolution. Special thanks today to our sponsor, Proactive International PR. So we have about an hour to discuss today's topic on satellite network solutions, development, evolution of capabilities and performance. So great to have today Frederick Morris, who's the VP Satellite Operators Market Vertical at Comtech EF Data. Tim Schroyer, CTO of CPI Satcom Antenna Technologies, as well as Xavier Wasser, Product Manager at Spacebridge. Gentlemen, welcome. I hope you're all well.
Yes, thank you.
Great to see you. Great to see you. So,
thank you.
What are we going to do, gentlemen? We're going to have a short introduction. I will do a little bit of a kind of an introduction to the topic. I will talk a bit about the objective that we would like to achieve, and then we'll directly go into the Q&A. So again, audience, please feel free to submit your questions through the Q&A function. So first of all, I would say, there are definitely these kind of unprecedented times in our industry. We see a lot of technology innovations. In the space side, we are seeing this development and launch of increasingly more powerful satellites, bringing more kind of throughput capabilities in GEO and in GSO. And on the ground, we're seeing this kind of accelerated advance in capabilities of terminal equipment, all whilst being manufactured at a much lower cost. So today we'll focus our discussion on these underlying drivers of technology advances and what is the impact of them on enabling new applications. We'll discuss the impact of artificial intelligence, flat panel antenna technology, software-defined networking, and many more. Moreover, we'll look at how new technology capabilities and application will ultimately impact the end user experience. So without further ado, let me turn to the first question. So as I mentioned, we all seen this kind of rapid changes in the space segment, such as the LEO constellations, GEO VHTS, but obviously there are parallel advances in the ground segments that are kind of key to the success of the space segment. So my first question is kind of to understand, what do you see as the implications of these trends on your business, and how do they kind of influence your kind of technology development or product development initiatives? So maybe let me first turn it to Tim, maybe to get your views on that.
Sure, Nathan. We have been involved quite a bit with VHTS coming out, for example, in the things that you're talking about there. The Q and V band has been a challenge. Obviously, the higher frequency requires more precision on the reflectors for the antennas. So that's one of the big developments that we've done. We have been in the forefront of lots of the higher frequency work over the years, having done the AX TT&C antenna that flew the AX satellite and proved K band. We did the antennas in Europe that proved K and then Q and V there. And so now we're starting to build some of the first VHTS. So that's the kind of thing that's pushed a lot of the technology that we've done, as well as CPI being vertically integrated in the amplifier business. We're actually building vacuum electron devices as well to build higher power amplifiers for those V-band applications. So that's been the kind of thing that the evolution in higher frequency technologies really pushed us.
And how does the NGSO constellations come into play for your business at this point?
Well, that's an interesting question, because we have done, for example, we did a lot of user terminals for O3B several years ago that much of their service was provided on our user terminals that were not what they wanted to buy at the time. They wanted phased arrays, electronically steered antennas, but we did mechanically pointed 1.8 and 2.4 meter antennas. So we've done that sort of thing. We see a lot more, obviously, of NGSO business coming. We have some parabolic antennas that we're using for user terminals, gateways, and for some TT&C applications. We ourselves are not building phased arrays or flat panel antennas, but we haven't been doing gateways for lots of those kind of non-geo systems. Instead, we have been working in MEO and like O3B, specifically with SES. And that's the kind of participation we've had in that part of the market.
And then maybe just one final follow-up question on it. So let's say in a Leo environment, would it kind of require a lot of, let's say, new R&D? You have the, for the MEO capability already developed. Is this a kind of a long development process, or you would say it's more evolution kind of technical?
Yeah, for the gateway antennas, it's more an evolution. CPI did provide gateway antennas in the past, and what we found was it was pretty expensive. And the cost really was pushed down in the marketplace, so the margins were not particularly attractive. We've done some development to do some more of those, but from our perspective, there's a lot of competition in that marketplace that's pushed the costs down and pushed the margins down. So while we've done some other development afterwards, we weren't as aggressive in that part of the market. We felt that there were other pieces of it that, like the TT&C, where the reliability and performance is really higher, that were better suited to the kind of products that we had been developing.
Yeah, great perspective. So Fred, maybe turn it to you. Same question. So how does the GEO kind of VHTS and the LEO constellations kind of impact your kind of development strategies or your kind of products and services?
Well, thank you, Nathan. Well, one of the directions that we've been going in is that we have a push towards adding product features virtually to other products. So these are products that are commonly used together, and we, if you will, put all of the functions into one box wherever possible. There's always been a demand for products with higher performance and more features. Space segment technology improvements increases that pressure sometimes, but they're adaptable. With the Tim brings up O3B. One of the things we participate with O3B, and one of the things that we had to do there was to take a off-the-shelf product and modify it such that it worked in the O3B environment, because it's not GEO, it's MEO, and that means that there's handover that happens between, as satellites pass overhead. So that had to be modified, but yet we wanted to do it. We did it in a way where you could take a GEO modem and use it in MEO mode, and then if you needed to repurpose it, you could take it back and turn it back into a GEO modem with just a firmware load. So that sort of thing is going on. On the LEO side, there's plenty of activity that's happening there, and we are always very interested in that sort of thing.
And the kind of technical challenge obviously get augmented by the number of beam handovers in a LEO environment. Is that something that, from a motor perspective, takes a lot of, let's say, R&D development to get to the reliable performance that obviously you want to achieve, or is this something that from your perspective it's something that it's within the realms of possibilities to achieve today?
It's we have a product that can do it today, can be used for LEO, MEO, and GEO, and one of the things that there's things that you have to take in mind. It's not only the handover. These are satellites that are moving relative to the Earth pretty fast, and there is Doppler effect that happens, and the Doppler has to be accommodated. And there's been clever ways of doing that with multiple different products, and we've been able to implement those, or if not implement them yet, design them. But that's one of the issues that you have with LEO and MEO. It's a very, very high Doppler quick handover, and that has to be taken into account. I think that so far it seems like people, from an antenna point of view, it's not on the gateway terminal, but on a user terminal. That's where one of the future questions that you've got. So
yeah,
we'll touch upon that then.
We'll that soon. Yeah, I think obviously it's a key topic for discussion. So maybe moving it to Savion. Welcome. So similar question for you. At SpaceBridge, how do you see these kind of new developments in GEO and in NGSO, and how do you develop your kind of project development strategy around that, and you're, product manager, right? So I'm pretty sure you're looking at that on a day-to-day basis.
Yes, that's correct. So first, I want to thank again for the opportunity to be part of this forum representing SpaceBridge. I'm very happy to be here today. So to answer your question, I would say it's at a high level split between three different efforts. The first one is obviously supporting our legacy customers, and we're going to release very soon a series of new terminals that are going to feature an independent compute element that is going to be basis for a lot of the capabilities that we're going to build on top of for future, both in terms of expanding compute power for existing applications and basically putting a baseline for other third-party applications as well. And so this is another very active avenue was supporting our first HTS opportunity actively with OmanSat. This has been a very active project on one of the first HTS satellites in the market. And during the course of the deployment, we learned a lot about the different requirements that come with this kind of a beast, and also with hand-holding the end customers on a daily basis. So this was a good experience into what kind of clientele, what kind of, on the operator level, what are the requirements when you get into a different set of complexities. And on the more strategic horizon, based on the lessons that we have learned, we are now building our next set of capabilities on the gateway side to accommodate for very high capacity, very high flexible multi-channel receivers, and also looking into splitting our basically, I would call it satellite and the traffic handling applications into independent software pieces that can still work together in different compute environment.
Great. And so just to maybe as well, and touching maybe a bit again on the LEO constellations, do you kind of develop specialized products for that, or would you kind of more looking for a product that kind of is multi-orbit, multi-frequency, or this kind of solutions? What is the angle from SpaceBridge on?
Yeah, so so the angle that we tend to take is again looking at this from a holistic point of view. Fred mentioned here the example of the Doppler effect that needs to be taken into account. That's one facet of it, but at the end of the day, what's common for MEOs and LEOs is that you get a lot of moving parts on different levels. So it all boils down to developing resource management control plane for all these different elements that can eventually work together. So this is where we are kind of architecting our next generation system to put all these elements together at different levels and figure out how they can work together so we can approach these constellations from a holistic point of view.
Great, and holistic is actually the perfect segue to my second question. Definitely, we're talking in these terms of industry terminology. There seems to be the shift, right, to thinking of the VSAT in a more holistic way, improving kind of as well what we see of these trends to improving user experience by putting more intelligence in the terminal. So, what is your view on this? And maybe it differs as well on user terminals versus gateway. So maybe just some understanding a little bit more what this kind of trend in terms of putting more intelligence on the terminal itself, and how do you see that to go forward in the coming years? So maybe first, Fred, you can give us your opinion there.
Sure. Well, Nathan, this shift is certainly going on, and I think one of the starting points for it was in the aero market and in military applications, and those are driven by size, weight, and power of what you have at a remote, and that needed to be minimized as much as possible. And so the direction was to minimize that in the RF section to meet those size, weight, and power requirements. We've approached this in one way where we have an embedded single board computer that we have on our remotes, and that enables edge computing to go on at a remote site, so that there's certain services and applications that don't have to go over the satellite link, and they can be performed locally. So that's one way to address your question.
That's a great example. Tim, how do you view that kind of holistic view and the intelligence putting more into the terminal? Is that something?
Yeah, we built a whole range of different kinds of terminals, of course, and with very large gateways, VHTS, that sort of thing. Obviously, there's the massive intelligence for the whole network control that's really running things that we don't build, but we integrate in with our customers that are putting those systems in. On the smaller terminals, and especially military tactical terminals, as Fred was mentioning, we've done several of those where the important intelligence was initially just satellite acquisition, that we did auto acquisition ACUs, maybe be able to be sure we were pointed at the right satellite, could peek up and then control the links that way. That's really the kind of first installation of intelligence in the terminal we've done. Since then, there's been more automation with specific systems that have been really driven by, from our perspective, the customer application. You know, if it's a network that operates on one of the modems that one of these gentlemen build and the kind of systems that they put together, then that's really what drives us on the RF side of it. So the intelligence comes more from the network control and the modem interconnection than us just implementing the RF pipe to connect it back through.
I see that. And looking moving forward, do you see there's any kind of use of AI machine learning in your type of products that you're developing and delivering, or is it something that it's still more on the network operation kind of level?
It's going to be a little bit of both. I guess the first pieces of that, we have customers now that have a desire to switch between satellites, between orbits, avoid interference, that sort of thing. It's the satellite version of cognitive radio that we've done in the past as well. That's starting to happen. We've done that more on the military and government side of things, really, than what we've done lately. It isn't, so far, that's not been the thing that's been driving a lot of our development, because mostly the push has been simply to reduce cost on the RF and what goes on there. Instead of add additional functionality, it's been driven mostly by the cost side of it.
Good. Savion, same question for you in terms of, bringing more intelligence to the terminal. What is the kind of developments you see at Spacebridge?
Yeah, so again, the two facets that were mentioned here were first on the form factor, size, weight, and power, however you want to call it. It's the entire terminal package. For us in Spacebridge, it largely leveraged by our years-long experience working with integrators and antenna manufacturers to put complete turnkey packages. So this is something that we've been doing, and we're going to keep doing into the future. I don't see the need for that going away anywhere. It's just going to be different types of packaging into smaller fit form kind of solutions. And the other aspect is the intelligence, if you want to call it, the actual compute. So as I mentioned, we're going to be releasing very soon a whole set of modems that feature independent compute platform with the initial use cases that cater specifically to the targets that we're basically pursuing right now. So more on the optimization side. But the intent is definitely to open this compute platform for other third-party applications that can benefit all the other use cases, software-defined networking, commissioning, a whole host of systems that I definitely envision an ecosystem that can be developed around this open compute. Obviously, it has open computers challenges of managing the environment itself, but this is something that is definitely on the horizon.
Very good. And the importance of artificial intelligence, machine learning, in your view, is this increasingly getting important, and how do you tap into it from a space perspective?
Yes, absolutely. It's definitely going to something that we're definitely going to hear about more and more. I think as we're just beginning to see the large constellations appear, I think mostly the artificial intelligence is going to be on the areas that service providers are more comfortable right now, which they have more experience. It's more on the service provisioning and commissioning, troubleshooting. So automating these kind of tasks is going to be the first kind of foray into artificial intelligence. The thing about we throw a lot AI ML in as terms, but we need to remember that in order to make this happen, we need tons and tons of data to accumulate over quite a hefty capacity, and then we need time to develop learning algorithms and then start making sense of them. So this will take time until we gain some operational experience with the actual constellations themselves. But this is going to be the future where this is going to go.
Great, great. So yeah, before well, I'll do one more questions, but please, in the audience, feel free to submit your questions through the Q&A. We'll turn to that after addressing these. Already Fred kind of alluded to it earlier, the flat panel antenna technology, right? It's one of the big things in the news lately. A lot of discussion around about availability and maybe about the performance, about the cost. So maybe try to understand from, I'll start maybe with you, Tim, but just first, maybe in your view, the importance for the industry, but it's also, you mentioned a lot of bringing the cost down, right? In terms of your on the ground antennas and, kind of the biggest kind of focus you've been having. So how, from your, perspective, do you think that bringing the cost down is this biggest challenge as well for FPAs, and just some of the views on that? And maybe let's start there with you, Tim.
Yeah, I think there's really two pieces of that are fairly significant. Bringing the cost down, obviously the big one. The big LEO communications constellations business plans really rely on the development of a low-cost, attractive user terminal, electronically steerable phased array that makes the terminals reasonable for installation and operation. Maybe they're getting there, we'll see. We did our first flat panel antenna more than 10 years ago to prove that we could actually build flat panels, but then we didn't go into production with them. We didn't see a way to get to the kind of cost point and performance point that we thought we really needed to do. And we were going for a higher cost point at the time. They were really initially developed by us for military applications. We'd been doing parabolic SATCOM on the move. We saw a need to do even lower profiles and did some flat panel antennas there, but we didn't see that we could get to the price, to the cost that we really needed to do with that. We've seen a lot of development since then by a number of different companies. It's certainly bringing the price down, and maybe it's putting it into the point that those big LEO constellations are now going to be able to close their business case. The other thing that happens, though, is the RF performance. Unlike a parabolic antenna that even if it's small, you can guarantee what the RF performance is going to be, both on bore side and with adjacent satellites, and you can deal with the interference in a very predictable way. With any flat panel antenna that is electronically steered, whatever the technology is, the beam width is going to change, the power density is going to necessarily change, the profile with adjacent satellite interference will change, which adds a whole nother level of complexity to network control to balance that, compared to the way we've historically done it with geosatellites. And power spectral density is really what has been controlled to do adjacent satellite interference. So the flat panel antennas, even if you get to the right cost point, there's this huge problem with adjacent satellite interference that we aren't seeing it yet, because it's not happening. There's not enough of it yet to see what goes on. But I think that's going to be a giant challenge, which flat panels will induce on other systems as well, regardless of how they work. So I think that's going to be a big challenge for all of us in the industry. And obviously, lots of those big LEOs, it's all based on that. So it's going to happen, just a question of when.
Good. Fred, your views on that? Do you echo some of the comments here, or do you have some other views on what are kind of maybe first the challenges, and then we can bring it as well what the opportunities it would bring for example, for contact in particular as well. But maybe first a bit more on the challenges you feel you see on the FPA development.
Sure, Nathan. And Tim's brought up some very excellent points on the technology behind the flat panel antennas and the implications of implementation in networks. And certainly interference is a potential issue but they all seem to have some sort of an answer for that, of all of the different flat panel manufacturers, whether it's electronically steered or not. There seems to be some progress, technical progress with that. But certainly, if it's not the biggest challenge, it's one of the bigger challenges in the satellite industry to develop the flat panel antennas. There's also a commercial aspect to this. The cost bar has been set with existing antennas, and even if they're mechanically steered. And so for a fixed site installation, customers may be willing to pay a premium for a flat panel antenna. Well, what's that premium? Is it 2x, 10x? It's a market scaling issue, and subsidies for these antennas may be required to accelerate deployment and development.
Yeah, and bringing that argument forward. So obviously there are some market segments that are maybe have more appetite or be able to accommodate some of those prices, right? Obviously some of the mobility markets. So do you see that it potentially can just limit it to some markets? And you're very strong as well in the backhaul and in the trunking. Do you see an opportunity there, or do you think that that's less likely, at least in the near term, to be an option?
Well, there is a manufacturer of flat panel antennas that is actually focused on cell backhaul as well as satellite, and also with microwave. They're thinking that they've got a big play there. I don't want to do an advert for them, but there are focus on that also, because after all, some of these materials that are used with the flat panel antennas can be modified slightly to be able to do different frequency bands, and microwave is not that far away from satellites. So it's that we can probably see that. And from a financial standpoint, if you can point to multiple markets for different products, then yes, that's going to take off. There's not enough commercial aircraft and probably not enough shipping to be able to, and even shipping, I don't even know if you'd want to use a flat panel antenna on a cargo ship. What would be the point, but on a commercial aircraft, certainly, but then there's only so many.
You need to scale with let's say the more broadband.
You need scale, and that you might get if you cross into different markets, microwave and satellite.
Yeah. All right. Maybe Savion, I'm happy to get your thoughts on this too. Obviously a big topic, and get your views on that. I'm kind of quickly look as well through the Q&A questions. So, but first your comments on the FPA topic.
Yeah, sure. So first, from a SpaceBridge point of view, this is a great learning time for us to learn about what's available in the market in terms of flat panel antennas, and making sure that we are well positioned to be integrated with them when the market opportunities will come. So I have to add on what Fred and Tim have said, which I agree with both, is in addition to I think it's pretty clear right now even with some of the advancements that were made in the past couple of years, let's say, we're still far from making the flat panel antennas, whatever flavor they are, to be kind of an enterprise equivalent type of a product. It's still going to cater to prime opportunities where you really need this kind of form factor, and the operator and the customer can get away with the high cost. I don't see these changes in the next few years, and it's being mirrored by some of the antenna manufacturers trying to move into straight equipment sales to experiment with other kinds of service-oriented offerings, which it's still yet to be remain whether they're going to succeed or not. But yeah, we still and also we should also remember that in addition to the scarce market on the aero side, for example, we are also still in COVID times where everything, especially in the maritime and the commercial aero market, has been significantly slowed down too. So this even compounds the challenges for flat panel antennas today.
Yeah, definitely an additional layer of challenging environment for operating in those two segments. Let me now turn to the first audience question. So maybe stay with you, Savion. So here is the question: how do you see virtualization within IF/RF changing the industry? So Savion, if you can unmute. Yeah, thank you.
Okay, great question that can be taken to all kinds of directions. So I'm just going to tell you how we at SpaceBridge look at this. I think there's a lot of premise and a lot of talk about cloudification and virtualization, and as we look around us in the digital world, we kind of see that this is where the world is going, and we always also want to figure out how we can reap the benefits from that as well. But as we look into the bits and pieces, some of the classic satellite, first of all, there's always going to be some hardware that's going to be very specific for satellite in terms of RF antennas that will require still a lot of hardware engineering orientation. This is probably not going to go away, that this is going to get more complex and probably at reduced costs. So in terms of virtualization, it's more about the first of all how to handle the traffic itself in a scalable manner, and on top of that, how to overlay other services that can take different directions, such as managing resources, user interfaces, and things like that. So virtualization has a lot of promise, but we're going to be very careful and very deliberate in how we implement and virtualize different types of components. I think there's still a lot of legacy in the industry of on-prem equipment. There's definitely an appetite to try to get into cloud, but this is going to be in stages and gradual. So we are architecting our next generation platform in a way that you can put different pieces of your software either within your on-prem or within a cloud environment to cater to all these different types of use cases.
Maybe Tim, do you want to address as well this question about virtualization?
Sure. First of all, virtualization doesn't have to happen as a big bang, all or nothing. And I think virtualization is going on right now at several different levels. There's going to be a lot more of that coming. We're participating in virtualization right now. For example, the Earth observation market tends to be a lot of that virtualized. The service providers that are there people like KSAT, SSC, are operating virtualized networks where they can change the modem waveform, change the antennas pointing different satellites, and then all the data comes down to the cloud and gets distributed virtually there. Those are using our antennas mostly, or orbital systems antennas from CPI. So we are participating in virtualization there right now. We also build M&C products that virtualize control of the RF equipment. Doesn't matter what it is that it's connected to, the interface is the same, it's virtualized, the way the network can interoperate with SNMP or manually through the higher levels of control. That's a level of virtualization as well. But as far as virtualization of the IF and RF stream, obviously that's coming. We were one of the first entities that ever did L-band IF, and I think digital is going to replace L-band over time. There's going to be different approaches that a big VHTS gateway terminal is not going to operate the same way that a single channel military deployable terminal is going to operate. So the virtualization is going to look different in each of those different scenarios, even though it might be based on the same kind of technology. So I guess what I see is that there will be developments to do that. We've already started on some of that ourselves. We see advantages that we can gain with efficiency with amplifiers, for example, that we can't really do today in the analog world, but as well as we can with digital. So we're looking forward to taking advantage of that to get higher levels of power out of the same amplifiers that we build today with digital pre-distortion. It'll be sort of an offshoot of the virtualization that comes as well. So we see it happening. I don't think it's the sort of thing that the switch is going to be thrown and it'll change overnight in the industry. But obviously, it's going to be pulled through by customer requirements, and it's going to help reduce cost in places where we use it, and then increase functionality at the same time.
Great. Maybe moving to another Q&A or another question from the audience. So we have things we're getting more and more, so please continue to submit. This question is from Alvaro Sanchez. So I will address it to you, Fred, first. So what is the biggest development for new capabilities and performance you have done, or well, Comtech as a company has done over the last year? So maybe you can give a bit of a brief on that.
So Alvaro, a shout out to you. So from the biggest that we've done in the last year, I'd say one of the things that we're doing, and this has virtualization built into it, is being able to create large carriers by link bonding, and being able to do load balancing on those bonded links, where you can take multiple different modems that are that have carriers that are on different transponders, different satellites, and combine all those together and be able to aggregate the capacity so that you may not have individual capacity available on a transponder to be able to support a customer requirement, but you sure can if you go to aggregated capacity across multiple transponders, multiple satellites, and even for customers that want to have terrestrial connections, even fiber connections, and be able to blend all of that together into one virtual trunk. So certainly we've seen that, and there are implementations of that already out in the field, and plenty more that have been designed and are in process. So yeah, that's one way of approaching it. But I think when people talk about, when we go back to the previous question, when we talk about virtualization, that's both, and I'm going to touch on something you said, Savion. There's both. It spans the hub, if you will, if you're in a VSAT network. It spans something as small as being able to just combine functionality in a virtual fashion using servers to be able to carry carry it, instead of having purpose-built products that do the functions, from that all the way to having large data centers. And the large data centers are really where the focus is, certainly in LEO networks and in MEO networks. That's where you see the large data center approach, and also with the larger satellite operators that are also service providers.
Great. Sorry. So Tim, maybe as well for you, could you point to what you consider one of the biggest developments in new capabilities and performance you have achieved over the last years?
Well, probably for us, the biggest technology advancement was really the Q and V band, push that up into larger antennas. We've done now 13.2 meter antennas that operate at Q and V band. We've operated as small as a 1.8. We have an SMC 1.8 meter antenna that's been qualified for Q and V band as well. So that's probably the thing we've been concentrating on from a technology standpoint. We've looked a lot at the LEO developments and what kind of antennas we should do there in different mounts. We've done different kinds of configurations with that, but probably the majority of the LEO work that we've done has been demonstrated in our orbital systems antennas that are used for LEO tracking, TT&C, Earth observation kind of applications. That those have been probably the two biggest areas that we've been doing development on over the last year or two.
Yeah, great. And I got a lot of questions about the SpaceX consumer antenna, their latest, what there maybe, do you have an opinion? Can you maybe, what is your view about it? I mean, seen a lot of technical reviews about it. So interesting to hear your opinion, Tim.
Yeah, my opinion, it was certainly a nice looking antenna. I think they did a superb job on it. I think most of us have probably seen one torn apart on the internet. That was a remarkable piece of engineering. They did a very good job there. The guy that tore it apart didn't understand what all the pieces were, but it was okay to look at that and figure out what they were instead. It's difficult to tell what it really costs SpaceX to build those, but obviously they're selling them now and have service on it. I think it's a very interesting development. We have not seen a way to get to that price point in the kind of developments that we've done of similar antennas. We haven't done one like that with the same volume, that kind of sophisticated design with phased arrays. Is interesting from our perspective. We build VSAT antennas with sheet molded compound and that sort of thing. So you compare what it takes for a GEO VSAT, and that antenna sells for very little. In the maybe $100, maybe $200 at the most, and compare that to what these LEO terminals are going to have to cost to be able to get the performance that's there. And I'm talking just about the antenna, not the RF. Obviously, once you add the transceiver for another $20 and the LNA for another $7, then things start to really add up. But the whole cost of a GEO VSAT compared to right now what we're seeing with the user terminals for the broadband LEOs, it's difficult to see how you get to the right price point.
Yeah, maybe Savion, maybe your opinion as well about SpaceX Starlink terminal. And as I see another question around this as well, so maybe related to it. So how is a traditional kind of, or as a product solution provider, how do you kind of prepare against this kind of Starlink? Do you see it as a threat, or how is your perspective, how that kind of plays into your potential market, their terminal? So maybe give your opinion on this, please.
Yes, that's an interesting question. It kind of, so first, I think our industry is still trying to figure out what to do with this kind of new entities that bring a completely different magnitude of development and resource horsepower into the industry. It's nothing that we've never seen in the past. And it's kind of hard to tell where this is going to go. And the interesting aspect of the SpaceX's and the Amazon Kuipers, just to give another name that is a behemoth, is that they kind of want to do things on their own and start from scratch, and they do seem to have enough resources to fall on their feet many times and learn and gain experience without learning any of the things that we've learned through many decades of struggling with the things that they're probably going through now. So it's going to be interesting how this all plays out in terms of market competition. It looks like at least the SatLink specifically is focused on a specific consumer market segment, which I don't think, at least between the three of us, is a core market for any of the participants here. So it's interesting to look at it from the side and see how it's going to shape up, how it's going to leverage any other tribal knowledge that we have in this industry. So it's mostly like that for me at this point.
Great. Yes. So maybe let's move again a little bit the topic from the technology point of view into what it basically means for kind of the market perspective as well. So first kind of question would be around the user experience, right? So basically to kind of understand a little bit, you have of course your ongoing relationships with customers, and you're directly in contact with them, and obviously you understand and see how the kind of end user requirements are developing. So the question is a little bit, is that kind of language changing? So is it moving away from ERP and to more like data throughput, cybersecurity? Is the language or the discussion that you have with your customers, are the requirements changing, or do you still see kind of the same requirement for maybe high performance and lowest cost? So maybe start with Fred. Maybe you can give your opinion on that first.
It wouldn't be a market if there weren't pressure on price in any market, I think,
sure.
and performance. But it's for satellite networks, you're always going to see the basics such as EIRP and GRT being taken into account with ground segment. But there's also the way that it's used, as you were saying, Nathan, the way that the product is used. And this is where the user requirements are coming into the fore of packets per second type of performance, and jitter, jitter is a function of network latency, changing network latency. Those 2 points are really important to any kind of service that you're running over a satellite link. Packets per second, not providing enough packets per second for some customer applications will slow the application down, give a bad user experience. And jitter in a MNO backhaul network, excessive jitter will shut an application down. The network will say this link isn't operating or operating incorrectly. We'll shut it down and bring it back up again. So that sort of thing can happen. That's MNO networks grade themselves on key performance indicators internally, and they track that sort of thing. So that's entered our lexicon at Comtech anyway for a while because of our focus on MNO backhaul.
Yeah, great. So maybe Tim, so do you see this kind of change or evolving requirements in terms of end user requirements?
Well, yeah, I think from our perspective, we tend to be suppliers of RF antennas, RF front end equipment. So usually our customers have already decided what they're going to do with the rest of the network and what their ultimate throughput requirements are, the rest of that. So to us, it's still a world of ERP and G over T and how all that is satisfied with the commercial world as well as military government side of it. That's certainly the kinds of things that Fred was talking about when you're building out the rest of the network, supplying the modems and the system that puts all that together. I think that's definitely changing, and that's a critical aspect. Our customers tend to be people that have already thought through that and decided which way they're going to go. And then basically we're sort of at the end of the food chain. Well, okay, I want this to connect together, build me an antenna that'll do this. So those requirements tend to still be the same that they were before. There's fewer people out there that are system integrators that can put all the pieces together and make that play. So we have fewer integrator customers than we used to have. We tend to do more of that ourselves and deal with just a few integrators. But ultimately to us, it still comes down to what's the RF performance that the customer is looking for.
Great. Maybe Savion, let's maybe as well move to another topic, which is obviously pretty important, is 5G. Definitely, thinking of networks and kind of the integral nature of satellite to 5G. Where do you see kind of the biggest opportunity for satellite in this 5G environment?
There's been a lot of talk about 5G in all kinds of contexts with satellite over the past 2-3 years. And I think it kind of mellowed down a little bit because it's at the end of the day, we're still well into an era of backhauling, both because of legacy, and also because of we have some prime markets that we're all pursuing right now on the backhaul business, on MNOs, on 3G, 4G. This is still a prime market for satellite in growing economies that we're just going to be focusing in getting more and more business to get a better footprint. And I don't think I'm telling anybody a secret about it. And as far as the future constellations, in terms of where they play into the 5G ecosystem, I still think that the design around them is more focused around backhauling. So in order to change the game of satellite in the 5G and move it to a direct device, if you will, kind of a medium, it would require a completely different approach. There are a few companies that are already engaged in that, and I think that this is something that requires extending the satellite ecosystems to other industries that do this on a daily basis, carriers that already have 5G offerings, and this is pretty much the only way it will work if you're looking at it beyond the backhaul classic role that satellite has today.
Yeah, interesting topic. Maybe address that to you, Fred, as well. So obviously the 5G, maybe first comment from 5G as a backhaul perspective, how you see the satellite opportunity there, but also maybe then to this direct to a device. Obviously, we see these new companies trying to aim that to deliver that type of service. What do you think about that particular opportunity?
Well, we're already involved in 5G backhaul, and we're looking at it in the way that 2G, 3G, and LTE benefited from satellite, and 5G will benefit from it. There is a group called the 3GPP inside of 5G that has a framework, and that framework for 5G, the use case for that, the first one for that, is likely to be Internet of Things. Now, there's a push to be able to use the synergies between wireless and satellite and use off-the-shelf cellular design chipsets in a satellite context. And that could open up a big market for narrowband Internet of Things. And also, there's satellite ground infrastructure that can be integrated into the core networks that come out of 5G. We're not looking at this happening next year. This is like LTE stands for long. This is a long-term evolution, but that could possibly happen, and we would have to adjust. We would adjust the way that we would be building equipment, and Savion would be alluded to this. 5G is probably the most friendly design for satellite yet, and and there are ways to be able to take advantage of that. So we could see that, and it really is proving out the marketplace for it. It's early days, though.
Tim, same question for you. I mean, I think we got already good perspective, but do you think this is still the early days, still takes a lot of time, or is there something that as an industry, or are we maybe too dependent on the terrestrial side to accelerate this kind of integration or moving in that direction?
Well, I think we as an antenna manufacturer, a terminal manufacturer, we see a lot of potential there, working with people providing the service, that we don't intend to provide the whole integrated terminal solution ourselves, but we want to work with other partners to be able to do that. Interesting that at the same time, there's the other impact of 5G that's happening here in the US and then in other parts of the world as well, where the move from C-band out of satellite C-band to be able to use C-band for terrestrial, for 5G. And it turned out that was, an interesting piece of business for us to help the major satellite operators move out of the C-band spectrum to be able to ready it for 5G. So the impact that it's had on us so far is that's been a bigger part of our business yet than doing 5G cellular extension, was getting the satellite operators out of that band so it could be used for 5G. But we see cellular backhaul and 5G and all the different technologies as a major part of the market going forward, and certainly we anticipate participating there.
Great. Yeah, we have a few minutes left, so people, still, if you want to submit your questions, please do so. We'll spend the last few minutes to address as many as possible, but we'll also make sure that after the webinar, the questions that have not been answered, they will be answered on the website. So please bear with us. Maybe the first question here is for you, Tim. You mentioned apparently about system integrators. So what are the major challenges usually reported by your customers?
Major challenges, obviously they have problems with just the cost and putting it all together. I mentioned before that there weren't as many system integrators as there used to be, that it used to be that our customers tended to be very satellite savvy, shall we say, so that they could give us specifications for the RF terminal that then we could respond to specifically and just go down point by point, and they'd put it together and make it play. We don't see that as much anymore. There's still customers that operate that way, but we see a lot more people that describe the ERP and GRT, maybe what they want on the satellite, but how the rest of the specifics come together in the terminal, that's not as much as it had been. That's probably one of the biggest changes, I'd say.
Great. Maybe for you, Savion, another question. Is there any possibility on virtualization to improve the antenna power capacity into the satellite network when the interference happens?
So maybe not at the physical level, but this kind of mechanisms, I can definitely see them playing when you have enough data collection that can make sense of it and adjust antenna patterns or antenna shaping, or on the fly power adjustment on both sides of the coin using some external intelligence. So I believe some of it can be done even dynamically today, if you have the right receiver infrastructure to adjust for power fluctuations. But this can definitely be augmented with some additional overall system intelligence that takes into account that a certain capacity is part of an overall collection of beams with that hosts certain types of traffic load and things like that.
Great.
So in short, yes.
Yeah. No, that was a good extensive answer to the question. Maybe another question. do you see any broadcast applications for NGSOs? Not necessarily mentioned by the Constellation themselves, but maybe Fred, do you see any opportunity there?
Broadcast is something that we haven't been involved in a while. The last time we were involved in it was with the Carrier ID initiative back a few years back. You know, I don't see why not. With NGSOs, you know, Russia had a satellite system using what we now call HEOs for a long time, specifically for video, because they wanted to get to the higher latitude parts of Russia, and that was all broadcast. The Monoya system is what that was. But you know, I don't see why broadcast. I don't think broadcast, as we know it, will exist well into this century. It's going to become streaming, and streaming applications will be found on any platform everywhere. I think you'll be able to do it on a Geo, MEO, LEO, HEO system, non-GSO. It's all on GEO system. That's where it'll be. That's what it'll look like. Broadcast, I think, is you know, unfortunately, it's what's satellite's strong at broadcast, and it's unfortunately probably going to be going by the wayside. But such is the way it is.
Good. Yeah. Okay. Gentlemen, our time is up for today. So this brings us kind of to the conclusion of the webinar. For the audience, you can watch the recording of this and previous webinars on gvf.org. Stay tuned for new announcements about GVF and Satellite Evolution Group webinar series schedule. There will be events in April, which will be produced in partnerships with Intelsat. I believe on April 20, there will be a new session about network connectivity in Africa. And on April 22nd, there will be a session dedicated to Europe, North Africa, and Middle East. You can find all the details on the website. Registrations are open. So with that, I would like to especially thank my panelists today for an excellent job to address as many questions we could cover today. As I mentioned earlier, the remaining questions will be answered on the website, so please feel free to check it out, as well as the video. You can rewatch the video if you want to see this again, or if you missed a part at the GVF website. So with that, I wish you a great day and hope to see all of you soon.